We are now moving on. We are continuing with flowcharts itself, and we are trying to understand what are the different types of flowcharts. The first one in this is called as a system outline flowchart. The first one in this is called as a system outline flowchart. Now, a system outline flowchart, as the name suggests, will be just giving the outline of a system, like what is the input, what is the process, where is the storage, and how is the output. Whenever we are talking about a system flowchart or a system outline flowchart, it is actually a very big flowchart divided into small subroutines. Now this subroutine is not elaborated. A subroutine is not elaborated. It is just shown as a block. I know it is difficult to understand what I am saying, but don't worry. I'll be giving you one example. Just first listen to this thing. I'll make this concept very clear. The system outline flowchart will be just giving you the outline of the system, showing the inputs, outputs, and the process. After that, we are moving to the next one, that is called as a system flowchart. This particular system flowchart will be showing you the details of input and output. Okay, and it will be showing you the process in between. Now also the process is not elaborated. Okay, after that, moving to the next one is called as a run flowchart. This run flowchart shows you how the data is traveling from one device to another device, from one process to another process. And the last one is called as a program flowchart. We just now said in system outline flowchart that subroutines are being shown. These subroutines now will be elaborated, and here it will be shown how exactly a process is running. Let me make this concept clear to you first of all. You open a world map. What you see is composition of various continents, and in that you can also see various countries, the outline of countries, right? So it gives you an overall picture of the world. In the same way, the system outline flowchart will be showing you an overall view of the entire business process. You zoom inside, and now you are focusing only on one country. In the same way, we move down one more step, saying system flowchart. A system is made up of several subsystems. In the same way, a system outline chart shows the various subsystems. That is called as the system flowchart. It gives the details about the inputs and the outputs and the process. Now, once you see the map of India, other things are not visible. So you see inside India now, you will be able to see various states. And that states is nothing but the next type of flowchart, that is called as a run flowchart. It is nothing but different processes and their input and output. Now also the process details are not given. Okay, zoom in further. I am talking about the last type of flowchart, that is called as a program flowchart. And that is nothing but zooming at a district level. Now, when you see a district map, you can see the roads, okay? You can plan your path. You can know which particular road is of what distance, okay? All these things, where to stop, which is a good place to stop, all these things you can plan. And that is nothing but a program flowchart, okay? A description is being given over here. Okay, we have a system outline flowchart which will be just showing you the input. Wait, don't immediately start writing here. We have we have a system outline flow chart, as I told you, which will be showing the input, files and the output. Going to the next one, system flow chart is the flow of the data, inputs and outputs. The run flow chart, how is the operations performed? What are the operations to be performed? And the last one is the program flow chart, how exactly the operations will be performed. Understanding? Okay. And that is nothing but the various categories of flow chart. Okay, then after that, we'll start with decision tree. With this, I've finished off with flowcharts. I'll be drawing flowcharts, but not today. Hey, listen. We are now moving on with the next type of a mapping system, and that is called as decision tree. Now, this is that mapping system which is exclusively used only for showing the decision making ability of a computing system. Or I would say, whenever n number of decisions are required to be taken, how exactly a program should work. Now, many a times we need to take decisions. Many a times we need to take decision. Like for example, after your 10th standard, after your schooling, you have to take a decision. What should I do? Science, commerce, arts. I'm talking about a decision tree. Now, in all the previous mapping systems, we learned about the relationship, that is the ER diagram. We learned how the data is flowing, that is the data flow diagram. We learned how a process works in a flow chart. But many a times we are required to take decisions. Like after your 10th standard, you are taking a decision what to do. It's a very intense process. After your 12th standard, you are taking a decision. Should I go for graduation? Should I do some diploma? Should I go in computer diploma? Should I do CS or cost accounting or chartered accountant? This is an intense decision. You have to think. You have to take a decision. After you have completed your CA, then you have to think once again. Should I start my own practice? Should I employ myself in some big corporate? Or should I enter into teaching? All these three options are open to you. But you have to think. If you are very smart but you can't speak, no one will accept you as a teacher. Understanding? Okay. If you are very smart and if you cannot handle clients, you cannot practice also. Then you have to do only job. 9 to 5 job. So you are required to think about various attributes to take a particular decision. Once you become a successful person, a very important event comes in life, and that is marriage. You are required to think about n number of attributes. Na? Huh? Girls, if the boy is very handsome, you will get married? Or there are n number of things which are required to be thought. Boys, there are n number of attributes which you are supposed to think. Yes sir, you are saying in that way that you have taken 4 decisions. Acha, coming back. All this decision making process will be made simpler by a decision tree. So in a decision tree, you will not see any input. You will not see any output. You will not see any process. You will just see an inverted tree, where the trunk, where the roots will be above and it will be going on spreading down. That is taking decisions. That is taking decisions. So in a decision tree, the first and the foremost thing to be understood is it's a supporting tool. It's not a full-fledged process indicator. It is just a supporting tool. What it will be supporting? It will be supporting the process of decision making. Then when you see it, it looks like an inverted tree or an inverted tree-like graph. It will evaluate all the possible consequences. See, we will not consider everything. We cannot consider everything. Okay, we have to choose. We have to choose between the consequences. Simple thing, a very simple thing, which you might have experienced or you might have been a part of it. A boy, are you getting the point? When you take one decision, you have to evaluate n number of consequences. Okay, that is n number of branches, and then you will be able to take a sound decision. So this particular decision tree will be showing you only the conditions that has been taken and the possible consequences. So we can say a decision tree is a complex problem solving technique. It's a problem solving technique. It is not a concept in its own, like the ER diagram or a data flow diagram or a flow chart. Okay? How exactly it is implemented? Let's see that. Let's take a very simple example where you are thinking what to do today. आज मैं क्या करूं? It's a very important question to be answered because it is not one question. There are several questions which will be creeping in and you are supposed to answer it step by step. How that is done, I'll explain. Suppose your parents are out of town. If your parents are out of town, maybe they go for 2 days, 3 days. Like for example, you are in your IPCC. I'm talking exclusively with the boys. You are doing your IPCC. Okay. Your mom and dad says, "Okay, we have to go to Tirupati." Tirupati is very near from here. Sorry. We want to go to Badrinath, Kedarnath, Bholenath, Shankar Bhagwan. There we want to go. It is a 8 days trip. 8 days trip. So they say, yes, come on, Satya, we are going for Badrinath. Satya will say, Appa, if 8 days I miss the class, then 8th day onwards I won't understand anything. I cannot go. I have to stay here. Satya is having a younger sister. So Appa says, me, your mom, then his uncle, his auntie, their kids, they are all siblings, they are all going. Satya stays at home because he has to attend the classes. Now classes is just for 4 to 5 hours. What about the rest? Satya says, hey, Satya, who is your one best friend in this class? Say anyone, na? What? So he is contacting Ram Prakash. Ramu, there is no one at my residence. What we'll do is, we will sit together and study. Then he contacts Mr. Nanda Kumar. He says, Nanda Kumar, we need to study and some accounts problem, you are given some accounts problem. We'll sit together and we will do group studies. Now Nanda Kumar is worried. Hey, what about lunch and dinner? Arey, no problem, yaar. We will order something from outside. Okay. Then this Mr. Hussain. Okay. Hussain says, hey, I'm also coming for studies and don't worry, I'll bring biryani for everyone. Veg. Okay. Satya, veg biryani is fine, na? Ha. Now listen, what I am saying is this is the scenario, okay, and in this particular scenario, Satya is taking a decision. The next day arrives. Now he is taking a decision, what to do. The day starts and he has to think whether his parents are coming back or whether they are visiting. Whether his parents are visiting. Okay. If his parents will be visiting, okay, then he will be going to a family function. See, in family function, we never like to go alone. अकेले जाके करूँ क्या वहाँ पे? पक जाएगा, बोर हो जाएगा. Family साथ में आ रही है तो बात अलग है. So if this is yes, then along with the family, he will be attending some family function. But if his parents are not coming today, if it is no, there is no question of attending any family function, then he has something to decide. He will check out the weather. आज मौसम कैसा है? Hello. How is the weather today? Now, there is the sun has come out. It's very sunny. So, it's sunny out there, and so he's saying, "Hey, Nandkumar, today we won't study. Today we'll play cricket." Okay. Chennai Super Kings versus Mumbai Indians. There is a match, and before that match starts, that atmosphere has to build up. Okay, so they say today we'll play some cricket. Okay, in the backyard we'll play some cricket. So if it is sunny, he is taking a decision to play cricket. Then it is raining out there like anything. It is raining cats and dogs, we say. There is no other option but to stay home. So this is the next possible condition that is happening, and I would say it is raining. So the output would be it is staying indoors. But the atmosphere is very soothing, or I would say there is a light breeze going on, or we can call it as a windy, light windy type of environment. So here comes into picture the third possible option. Okay, there is wind. Now, if it is windy now, or if the light breeze is been blowing, we always like to roam around. We always like to roam around. So he thinks if it is windy, I would be roaming around. But for roaming around, you require vitamin M. So he's checking whether money is available with me. Acha, listen. Shh. Money. Whenever we are talking about money, if the money, he has the money, lesser money or more money. Suppose he has ample of money with him. That means if he is rich, he will directly go for shopping and he will spend his money. He'll go for shopping and he'll spend the money. But if he is having only limited resources, obviously he can't go shopping. With limited money, what he can do is he can roam around, do window shopping, and while roaming around he will feel hungry, so he can buy some snacks and obviously eat it. Getting it? Now listen, hello. This chart or this particular tree is never ending. Am I right? I can go on continuing with this example, but it makes no sense. The idea is to understand how exactly a particular decision tree is being constructed, and this is it. If you want to go at a corporate level, collecting finance, it will be having two decision boxes. Popular, not popular. If you are popular, go for owned capital. If you are not popular, go for borrowed capital. Then in borrowed capital, again, there will be 2-3 conditions. Check out the interest rate. Interest rate higher. Okay, so get low capital. Interest rate lower, get higher capital. On this side, it will go on expanding, and that's how you are supposed to take a decision. And this exactly is nothing but something called as a decision tree. Are you understanding a decision tree? Yes, sir. Okay. So this is all about your decision tree. topic, and this is called as decision tables. That's the last type of the mapping system we are learning. And after finishing off with this decision table, I can say that I have successfully finished off with chapter 1. After this. Okay, let's start. What is a decision table? Now, a decision table will be showing all the possibilities that is shown by a decision. And many a times we are required to take decision based upon several conditions. Okay, like for example, a shopkeeper allows credit facility, but he allows credit facility based on some conditions. And the conditions are, it is also the problem. We will be solving this problem. Now this particular decision table is quite lengthy and it is quite complicated. We are checking whether all the conditions are being satisfied, and we are again rechecking whether all the possible conditions are being checked. Many a times what happens is the conditions are repeated. So those repeated conditions we remove. So it is actually a 4-5 step procedure. I will be constructing a diagram, a table for you. Each and every step I'll explain. Okay? And then you can take down. First things first, a shop owner allows a credit facility to his customer if they satisfy any one of the following conditions. Any one condition has to be satisfied. Number one is, he has to hold a job for 3 years. That means he should be permanent somewhere, or he should be stable person in the same place for more than 5 years. For more than 3 years. And he should be residing in the same place for more than 5 years. This is first condition. Acha, if this condition is not followed, then there is other criteria also, like the monthly salary should exceed rupees 1,500, and he should be in the job for more than 3 years. There is third criteria also. He should be residing in the same place for more than 5 years, and his salary should be greater than 1,500. If any one of the condition is fulfilled, the shopkeeper will give credit, else he will reject the credit. So we are supposed to draw a decision table which will give you the complete picture of what are the available conditions and what is the output of the condition. Depending upon the output of the condition, the action has to be justified. This all things are shown inside a decision table. A decision table is divided into 4 parts. It's a rectangular box with 4 parts. The top left part will be showing all the available conditions. That is also called as condition stub, S-T-U-B. The top right hand side will be showing all the rules. This is yes, this is no. This is yes, this is no. This is no, this is no. All permutations and combinations we will be studying. How much to study? For that also there is a formula. We will be learning. On the lower left hand side, what action will be performed? That is also called as the action stub. And on the lower right hand side, we have the action entries. That is the output of a given condition, output of a combination of conditions. This is nothing but the preview of a decision table. Listen, condition stub, action stub, rules, action entry. Got the 4 parts? But how many rules we should put in? For that I said there is a formula. This problem has to be evaluated step by step. The first and the foremost thing is, I'll first note down what are the possible conditions. So that is, I'll call it as conditions and the possible actions. Conditions and the possible actions. I will name, girls, please don't write, please don't write. Concentrate hard. I will name all the conditions as C1, C2, C3, C4, C5, C100, whatever conditions are available. And whatever actions are to be performed, I will call them A1, A2, A3, A4, A5 and so on. Okay. So when I see this particular question, I can see holding present job for more than 3 years. This is the first condition. So I put C1, that is holding present job greater than 3 years. Okay. Second says the monthly salary should exceed rupees 1,500. Clear cut it is saying. Okay. So I am saying C2 monthly salary should be greater than rupees 1,500. Okay. The third point in this problem says residing in the same place for more than 5 years. This is the condition. Next condition, I am calling it as C3. Residence, same place, greater than 5 years. Okay. Acha, now next. What are the possible actions? What can a shopkeeper do? He can allow credit or not allow credit. That comes in A1, allow credit. Allow credit facility, or the other action he can perform, and that is reject the credit facility. Okay, this is done. So now the table's left corner is finalized. That is called as the conditions tab. And the table's lower left is been completed. That is called as the actions tab. Is it fine? Now we are supposed to draft the rules. Rules drafting works on a formula, and that is number of rules is equivalent to 2 raised to number of conditions. Okay, that's the B part coming up. Finalizing number of rules. What is the formula? It is number of conditions, number of rules equal to 2 raised to number of conditions, which is equivalent to 2 raised to, there are 3 conditions: holding present job, salary and residence. To 2 raised to 3. 2 into 2 is 4, 4 into 2 is 8. So now we have finalized. There has to be 8 rules. Okay. Step C is prepare decision table. Third step is prepare decision table. It is quite obvious, it cannot be fitted over here. Okay, so now I am preparing a decision table. Scale. So in a decision table, I require a rectangular box. Okay, the first part is a condition stub. Right? How many conditions are there? Three conditions. Let's say C1, C2, C3. Okay, and how many rules? Rules are on the right hand side. Acha, but I'm sorry, before the rules, I had talked about the action stub. So here we will be having the action stub with two possible actions, A1 and A2. Acha, let's note down the conditions. We will just we will compress the conditions wording. First was holding present job for greater than 3 years. So I would say job greater than. Second condition was having monthly salary greater than rupees 1500. So salary obviously rupees, and having a residence living in the same place for more than 5 years. So residence should be greater than. Now in the action stub, what are the possible actions? First one is allowing credit or reject credit. Okay, chalo, I'll give a proper presentation to this. Let's give a longer scale. Hey, can you see this? Please don't discuss. Now, listen, right hand side, top right is rules, and this is action entry. Now, how many rules are there? We have just calculated 2 raised to the number of conditions. So 2 raised to 3 is 8. So I will be having 8 equal parts. This is shit. Okay, forget about 8 equal parts. I'll be having 8 parts. One, 2, 3, 4, 5, 'Arey, I don't want to waste. I don't want to waste time on presentation. Equal, it's fine. You are understanding ना? भावनाओं को समझो. अच्छा, listen. How many rules are there? So we are saying R1, is it okay? Is it fine? Now, every condition has yes or no, and there are possible permutations and combinations. So you will start from condition 3 or the last condition. You will say yes, no, yes, no, yes, no, yes, no. The line above that, okay, you will now merge yes and no's. So yes, no, yes, no. Further combination is possible. Now listen. Hey, listen. Now we will analyze what action is being performed. Okay. Now check the first condition. Is the job greater than 3 years? Yes. Is the salary greater than 1,500? Yes. If these two are yes, obviously he will be allowed credit facility. So you need not check this, and even if you check this, it will come to yes only. Is the residence greater than 5 years? Yes. So don't you think he has to get credit? Yes. So action is allow credit. Hey, what it says? Allow credit. Now we will be following the rule 2. Listen, hey, please. Is he holding the job for greater than 3 years? Yes. Is he having the salary greater than 1,500? Yes. If these two conditions are satisfied, it is yes. Just check the third one. Is he residing for greater than 5 years? No. But it will not make any difference. He will be getting the credit facility. So the action entry is allow credit. Okay. Then the third one. Is the job greater than 3 years? Yes. Is the salary greater than 1,500? No. But check the third one. Is the residence greater than 5 years? Yes. Then he will get a job. Yes. Because at least two conditions are satisfied. Sorry, he will be getting credit. Okay. Now, hey, listen. Check the fourth rule. Is job greater than 3 years? Yes. Is salary greater than 1,500? No. Is residence more than 5 years? No. Only one condition is satisfied. So obviously he won't get credit. So reject credit. Okay. Check the fifth rule. Is the job greater than 3? No. Is salary greater than 1,500? Yes. Is residence greater than 5 years? Yes. Two conditions are satisfied, so credit will be? No. Now check this. Job greater than 3 years? Same thing, na? Okay, chalo. Is job greater than 3 years? No. Is salary greater than 1,500? Yes. Is residence greater than 5 years? Only one condition, so it should be rejected. Then 7. 2 no's, 1 yes. All 3 no. Kick that person out. Getting it? Understanding? This is not the end of the story. This is the basic decision table that we have created. Now, there are some rules which are repeated. How to find out that? See this. They are both adjacent, right? Actually speaking, only 2 things are required to be considered. Yes, 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 yes. So don't you think this is repeating? This is repeated, na? So we can combine R1 and R2. Now this cannot happen, this cannot happen. Here it can happen. Why? Because anyway, see, this is no, this is no, this is no, this is no. Actually speaking, the output will be the same for both the rules. That means we can combine this and this. Right? Now we will be drawing a reduced decision table, a smaller one. Again, the same thing is required to be done. This was the first thing we did. This is the second page. A, B, C. Now I am going for the D part. Third page. And this is called as combining rules having similar actions. Okay? Or I would say combining rules having similar actions. Or the most appropriate thing to be said over here is combining the rules having, I'm using a word which is used in database management systems, that is called as redundancies, and redundancies refers to repetition. It refers to what? Repetition. Again, same thing is required to be done. I am doing it. You should have patience. Can't help. What was the first part? Okay, 3 conditions, C1, C2, C3. In short, we will write, what was the first condition? Job. Second one. Third one. Hey, my dear students, when you copy this, you write full word. Residence greater than. Then there was okay, 2 actions. Action 1. Second part. Okay. Now listen. Shh, please. Just now we said that these 2 rules can be combined. So 1 rule less. Then we said these 2 rules can be combined. That means 1 rule less. Okay? 1 rule, 1 rule. 2 rules less. So it comes to 6 rules. Now I'll be having 6 rules. One, two, three, 4, 5, and now please check. Hello. Enough. Let's start. We have now 6 rules. R1, R2, right? And this is okay, these lines are not required. Acha, now let's start. What we combined? 1 and 2? Check out 1 and 2 simultaneously. Yes and yes. Yes and yes. Yes and no, obviously it is. Okay. Yes and no, I cannot write yes, I cannot write no. So, I'll put a dash. And what's the result? What is the result? Now, check the rule 2. Yes, yes and no. What happened? Hey, R2 is gone. Check the rule 3. Yes, no and yes. So yes, this is no and this is yes. We have it is not visible. Okay, okay. Check this. Check this. Yes, yes and yes. We combined it with R2. Yes, yes and no. Now both the rules will be evaluated simultaneously. Yes and yes. So I wrote yes over here. Okay. Then yes and yes. I wrote a yes over here. Yes and no. I cannot write yes, I cannot write no, because both the things are possible. So I am just leaving it by a dash over here. Now the action entry is allow credit. R1 and R2 is over. Now I am starting with R3. First is yes. It is not combined with anyone, right? So yes, no, yes. As it is, you have to copy. So in the reduced decision table, yes, no and yes. And the result is allow credit. R3 is done. Now the R4 part. Yes, no, no. Here it will be in R3. That is yes, no, no. So it will go in the reject credit. Now here R4 is over. Now R5. Check out R5. No, yes, yes. Okay. It is not combined with anyone. So we are saying no, yes and yes. So it is allow credit. After finishing off with R6, we are moving now to, now we are moving to R6. After finishing off with R5, we are now moving to R6. It is no, yes, no. No, yes, no. So the result will be reject credit. Okay. And just now we said कि 7 and 8 has to be combined. No, no will be. No, no will be. And for yes and no, I cannot write. And what is the condition? What is the action? Did you get this part? Now we have to check for its completeness. Because we are reducing the table, it does not mean that some conditions are skipped. So we are supposed to cross check it whether all the conditions are satisfied. For that, we have to use a formula. Fifth part says check check for completeness. Now how the completeness will be checked? How the completeness will be checked? See, listen. Whenever you see a dash, okay, you have to consider it as 1. Okay? And if there is no dash, you have to consider it as 0. Computing is all about zeros and ones. Okay? So now I am writing a formula. I am writing a formula for rule 1. I said 2. For dash we have to consider 1. So I am saying 2 raised to 1. Now for rule 2 it is 0. So I say 2 raised to 0. For rule 3 no dash means 0. So I say 2 raised to 0. For rule 4 no dash means 0. So I say 2 raised to 0. For rule 5 2 raised to, and for rule 6 there is a dash, so 2 raised to, understood? Solve this. Anything raised, 2 raised to 1 is, anything raised to 0 is, here, 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 here. I need to add all these. Wait. 2 plus 1, plus 1, plus 1, plus 1, plus 2. 8 is nothing but the number of original condition. So this is equal to number of rules. And we can say hence table is complete. Understanding? बजाओ ताली. Hey, listen. Enough. There might be a question in your mind. Sir, why to do this? Even after 12 years of doing programming, I am finding the same answer why to do this. It is a complete outdated technique. Okay, no one is using it today. But because it is there in your syllabus, I scanned everything, learnt it first, and now I am teaching you. Okay? So please Take down the problem first. डिसीजन यही है, डिसीजन टेबल. एक मिनट में आता हूँ. Finished. Be careful when you are writing yes and no's. When you are writing yes and no in rules, be very careful. Don't forget to underline that cross. That is called as combining the rules. R1 and R2X, that is cross, is been underlined. Yeah, you can see it over here. And that tick mark and dot is not required. Huh? That is actually for noting, copying it into another table. You might be confused in the columns.
Finished.
Take down the question. Draw a flow chart to accept name of a student his division A, B, C, D, whatever, his division, age and average. Full stop. Display it. Whatever data we are accepting, we are displaying it. Display it, IT it. Acha. Now listen. Now in this particular flow chart, there is some input. Can you make it out? We require the name of the student, his division, his age, and his average. And what will be the output? Whatever we have accepted will be the output. Am I right? Now, in this particular flow chart, see, this is a very basic flow chart, and here there is no processing. Immediately, if I start with a complicated flow chart, you will never ever understand how a flow chart works. So, this is a very basic flow chart which has an input, and the same input is being shown as output. How will you draw flow chart for this particular problem? Acha, listen. If you have noted the points, I said every flow chart starts with start, please don't write, concentrate, don't write. Maintain silence, boys. We start with start. Now, if I want to accept any data from the user, okay, the first thing I have to do is declare variables. Okay, so I am supposed to accept name. So I say set nm equal to space 10. Now what exactly it means? Set is nothing but a command for declaring variables. And nm is the name of the variable. Say name, name, name. So I have said nm. And space 10 is nothing but it indicates that whenever we are accepting name, only characters will be coming, right? Only characters will be coming. And how many number of characters? So we are expecting there will be 10 characters. So we are making a provision for 10 characters, right? What is the next thing required? Age. Sorry, division, na? So div, write something sensible. Div, division, equal to space 1 is enough because division will be A, B, C, D. So I am saying space 1. What is the next thing required? Age. So I am saying age equal to, no, age will be having numerical data. So I say age equal to 0. Okay, then what is required? Average. So I say AVG, average, equal to 0. Why? Because it is numeric. And all these things happen inside the memory. Memory means processing, and processing means I will have to put this inside a rectangular box. Understanding this part? Now we will accept the data from the user. For accepting the data from the user, we will say input. We will say what? Input. Input what? Name, then the division, then the age, and the average. Right? Once everything is been accepted, any other processing is required to be done? Directly we can put output. The question says display. So I am saying display. Whatever I had accepted, I am displaying it. That is name, division, age, and average. Now, display is the output. Whatever box is there for the input, that is parallelogram. The same box you have to put for output. Okay. This is task completed. And once it is done, we will say stop. Got this? Very simple. It is simple because it is having only input and output. We will be seeing some very complicated flowcharts. Decision making, looping, everything will come. Okay? For the time being, take this down.